Hello and welcome to another video of Learn with Vishran Bastula. Today we are going to learn about air pollution and its control, and we have already learned about the definition. Now today we'll be learning about clean air. So what all is the percentage of a clean air? So the earth is surrounded by approximately 500 billion tons of air, of which 20.9% is oxygen and 78.0% is nitrogen and 0.9% is argon. Including water vapor, this gas makes up to makes up all but 0.04% of the atmosphere, and 3/4 of the remainder is carbon dioxide. So only last 0.004% are carbon dioxide and other gases. So the last 0.01% contains other noble gases, hydrogen, nitrogen oxide, ozone, and traces of many other gases. Table 1.1 summarizes the major gases and their concentration on dry basis. These figures remains essentially constant as long as water vapor is not included, since it varies in range from as high as 3% by volume to less than 1% in ambient air measurements. This variation is normal within the relatively limited limits of the determination and can be ignored. Despite this, samples are often dried before testing. Water vapor normally cannot be considered as an air pollutant, even though it is produced in great quantity in combustion process. Natural evaporation and precipitation move far greater amount of water than any man-made processes. One exception of this may occur in the near future with the advent of the supersonic transport. This plane may release large amount of water vapor into the stratosphere, causing increased cloudiness and a temperature rise. So what we can see here is nitrogen 78.03, oxygen 20.99, carbon dioxide 0.03, similarly other remaining gases. So what we can see is like they are in very less percentage, though it is harmful, so though we are not that much, though there is not much of carbon dioxide in the atmosphere or other gases, harmful gases, but little bit of harmful gas is also very much it pollutes the environment. Water vapor has synergetic effect upon air pollutants, increasing mainly deleterious effect. For example, sulfur dioxide, which itself is an irritating and corrosive pollutant, can combine with water vapor and atmospheric oxygen to form highly corrosive sulfuric acid mist. Smoke also depends upon water vapor for its formation. Monitoring of pollutant in urban areas must consider the humidity and predicts its effect on pollutants. Pollution sources. So what are the sources of pollution? So major category of air pollution are considered to be caused by, first one is transportation, second one is domestic heating, electric power generation, industrial fuel burning process emission. So major industrial polluters have been classified relative to the types of industries. Generally, they can be categorized as petroleum refineries. So if we talk about context to Nepal, so there is no petroleum refineries. Mostly it comes from transportation, domestic heat, electric power generation, like in Nepal we do it by hydro project, so this is also not, I think it's not the case. And industrial fuel burning, I think this is the case, so particulate, sulfur dioxide, hydrogen, hydrocarbons and carbon monoxide. Major industrial polluters have been classified relative to the types of industry. Generally they are categorized as, okay, first one say petroleum refiners go सट्टा, yeah, this can be considered in transportation. Particulates भनेको different kinds of, okay, यसको भित्रपट्टि like they are particulates like के रहेछ भन्दाखेरि particulates, and sulfur dioxide comes from this petroleum refiners only. Hydrocarbons obviously comes from that, and carbon monoxide also comes from that. Petrochemical industries, hydrocarbons, carbon monoxide and particulates, this we don't have problem with, but this we have problems because this comes from transportation. And fertilizer industries, particulates like NOx, gaseous fluoride compounds. So fluoride compounds are also big pollutants, and we should be careful in that. Types of emission in petroleum industries, refineries, potential source of refinery emissions are in table 1.2. So let's learn about it, but to be honest, we don't need these refineries, because if we talk about in context to Nepal, it is not a big problem, but we'll go over through it. Okay, let's go fast. So atmospheric pollution in refineries. So an average emission factor approach in a combination of average emission factor and unit specific data, number of each type of equipment, bulbs, pumps, seal, etc. The service each equipment is in gas, light liquid, heavy liquid, the total organic compounds TOC, concentration of the stream and time period each equipment is in that service. The emission rate of TOC, total organic compounds from all equipment, can be calculated as following. Emission rate of total organic compounds from all equipment in the stream of given equipment type kg per hour मा चाहिँ के हुँदो रहेछ into FA into W FTOC into N, where what is FA, what is all that. So I think it's given down below. Okay, FA is applicable average emission factor of the equipment type kg per H per source, average emission factor of the equipment type. So कुन हो, अब it's a boiler हो भने boiler को average emission factor हुन्छ होला, like other pipes, bulbs हरू भयो भने त्यो अनुसार हुन्छ. Average weight fraction of TOC in the stream. So it's the average weight fraction of total organic compounds, and N is the number of pieces of equipment of the applicable equipment types of stream. So if there are two boiler, then N equal to 2. So table 1.2 is a potential source of specific emission from oil refineries. So potential source. So like if we talk about oxide, sulfur oxide, so it can be from boilers, from process heater, catalytic cracking unit, refrigerators, regenerators, and treating units, H2S flares, decoking operation, etc. If we are talking about hydrocarbons, there can be loading facilities, first of all from the starting, and turnaround, sampling, storage tank, wastewater separators, blow down system, catalytics, regenerators, pump bulbs, blind changing, cooling towers, vacuum jet, barometric condenser, air blowing, high pressure equipment handling, volatile hydrocarbons, process heater, boilers, compressor engine, etc. So oxide of nitrogen can be from process heater, boiler, compressor engines, catalyst, generator, flares, etc. Whereas particulate matter could be from catalyst, regenerator, boilers, process heater, decooking operators, incinerators. So aldehydes can be from catalyst incinerator. So there are other hydrocarbon can be from decooking process engine. So there are all of these factors can be all of these types of emission that could be happening in a emission in a petroleum emission. So from here we'll do in next video. I suggest people to fast forward the video and watch it, in a speed mode if you are feeling dizzy or sleepy. Alright, thank you for watching. Bye bye, see you in another video. We'll continue.